Dear student, today I'll be explaining about how the LR parsing algorithm works. I mean to say that how the LR parsing pass the given string. As I said earlier in the beginning of this particular chapter, the LR parsing algorithm works in this fashion. The string to be passed will be placed into the input buffer, and it uses an intermediate stack to hold the intermediate result, and it uses the parsing table to pass the given string, which consisting of two parts. One is the action part, the other one is the go to part. Whenever this particular algorithm reads an input symbol, it reads the input symbol and it sees what is the element which is there on the top of the stack, and then it consults the parsing table and it produces the particular action, and that will produce as an output. That output is nothing but a production used to pass the given string. So finally, the output will be used to construct a parsing tree. Now, in this particular algorithm, the configuration of LR parsing algorithm will look like this. So initially, my stack consisting of S0 followed by X1 followed by S1. Assume that this is my intermediate result, wherein which my top of the stack consisting of SM. That is, it means that after reading some input symbol, so the configuration of the stack look like this. So S0 was the initial state. After that, we have read some input. For that, we have posted some element, that is some symbol X1 followed by S1, which represents the state X1. Similarly, we keep on pushing the element, or might be we have popped the element. So after some intermediate state, we get XM, that is the symbol which you have pushed onto the stack, and SM is the state which you have pushed onto the stack. So this is my intermediate result of the stack, and the rest of the input looks like this, that is AI plus 1 up to AN, and the end of the string is $. So this is the configuration of the LR parsing after reading the part of the input string. Now, where at the intermediate stage, SM is on the top of the stack, AI is the input symbol. So based on this, decides the parsing action by consulting the parsing action table. Now, by looking at the parsing action table, you decide whether to shift an element AI onto the stack or whether to reduce based on the parsing action table. A configuration of LR parsing represents the right sentential form. So finally, it represents the right sentential form. Now, the action of a LR parser consisting of four things. One is the shift, the other one is reduce, the other one is accept, the last one is the error. In case of shift S, so shift the next input symbol and the state S onto the stack. So assume that this is the present state of the stack, that is S0 followed by X1 followed by S1. So it means that for X1 we have post S1. So in the other way, say that X1 is represented by the state S1. So similarly, we have post XM, that is M element onto the stack, and for that we have post M state onto the stack, and the remaining input symbol will be AI plus 1 up to AN. Now after reading AI, assume that you have post A onto the stack, then it becomes what? SM followed by AI. For that we have post S onto the stack. Now you can just observe that earlier your input was AI, now your input becomes AI plus 1. When it comes to the reduce, you know that the reduce will pop the element from the stack. So what it does is it pops 2 times the beta. See, for example, if the production is of type A tends to beta, so we are popping 2 times the size of the beta. So why we are popping 2 times the size of the beta? Because for every symbol, we are pushing symbol as well as the state. If at all, if my beta is 1 symbol, I have pushed the symbol as well as I have pushed the state also. If my beta has got 2 elements, then for that, what I did is I have pushed 2 elements whenever I'm going to reduce it. So for that, we have already pushed 1 element followed by 1 state, next element followed by the next state. So that's why we are going to pop 2 times the size of the beta from the stack. So after popping the 2 times the beta from the stack, so then what you are supposed to do is push A and S. That is, so you are supposed to look at you are supposed to push A as well as you are supposed to push a state S by looking at go-to part of the table. You are not looking at the action part of the table. You are going to look at the go-to part of the table. Now my top of the stack is A, and I'm going to push a state which is there in the go-to of SM minus R, comma, A. Earlier, whichever the state you add, after popping the so many elements from the stack, what you will do is, after popping 2 times the beta elements, you left out with Sm minus R. Now your top of the stack becomes Sm minus R, comma A, which will take you a new state that you are going to push it onto the stack. So then it becomes what? So your configuration looks like this. So S0, comma X1, comma S1. So similarly, it becomes XM, comma SM, and then AI. So once when you look at this SM, comma AI, assume that this is going to say that there is a reduce. Then what we do is we have popped SM minus R state, means we have popped R number of states. This R representing the number of elements which you have popped from the particular stack. So you are left out with Sm minus R, and followed by you are supposed to look into the Sm minus R, comma A, which gives you a new state S, which you are going to push it onto the stack. You can just observe that AI you are not pushed, you have reduced it to the some state. After reduction, you will be having a configuration. Earlier you had Sm, so you have popped so many elements from the stack. You have popped R element from the stack. That is nothing but 2 times the beta. So you have left out with Sm minus R. For that, you are supposed to look into the goto of Sm minus R, comma A, which gives you a new state that you have pushed onto the stack. Now my input is the AI up to AI plus 1 up to AN, which remains same. Now output is the reducing the production, reduce A tends to beta. You are going to produce an output A tends to beta as reduction output. Now accept. Now it means that when you find the accept, when you looked at the SMR AI, assume that you find accept, it means that string has been passed successfully. Similarly, if the parser cannot parse the string successfully, then you will get an error message. When you will get an error message, for example, if you are in a state SM and there is an input symbol AI, so when you look at the action part of the table, so you will find an empty entry that is nothing but an error. In that case, we say that error has been, a string cannot be passed using this particular LR parsing. So this algorithm works like this. So initially set input to point to the first symbol in W, that is you're going to point IP will point to the first symbol of W, and you will place initially the stack will have S0, and then repeat forever. What you're going to repeat is let S be the topmost state on the stack and A be the symbol pointing to by input symbol. Now you have an S on the top of the stack, that is the state, and A is the input symbol. So you are going to point. So then if action of S comma A, it is shift. If you have a S comma A, it is shift. Then what you will do is an action of S comma A, you are going to shift it to a particular state. Yes, then you will have a shift operation. So push A, then S onto the stack. So you're going to push A also, then you're going to push S onto the stack. Advance input to the next input symbol. So once you have read the input symbol and then you perform this push operation, I'm going to say that shift operation, they are going to advance this IP to the next symbol of the input symbol. So if it is not if the action part is not shift, if it is reduced, so if action of S comma A is reduced, it tends to beta. As I said earlier, pop 2 times the size of this beta symbol from the stack. You are going to pop 2 times the size of beta symbol from the stack. Let S be the state now on top of the stack. After popping 2 times the beta symbol from the stack, now the top of the stack is S. Then what you are supposed to do is you have to push A. Then you are supposed to push a state. Which state you are going to push? That is the S state which you are find after popping these states. That S comma A onto the stack. That is you are going to look into the go-to part that you will go to push onto the stack, and you are going to produce output as production A tends to beta. So else if action of S comma A is equals to accept, so you say that string has been accepted successfully and you will stop the parsing. So you will return successful, else you will return the error. This is how this parsing algorithm works. So consider an example. Now this is the one which you have constructed the parsing table using this particular grammar. So we'll take a string to pass the given string using this particular table. Now the string to be passed is ID star ID plus ID dollar. So you can just observe that my top of the stack is S. So in case of this, we are not pushing the element ID onto the stack. I mean to say that we are not pushing the symbol onto the stack. Either you can push the symbol onto the stack as well as the state also. So in that case, when you're reducing, you're supposed to pop 2 times the size of on the right hand side of that. But instead of that, what we are doing is we are just pushing the state onto the stack rather than pushing the symbol also onto the stack. Don't get confused. So here we are not popping 2 times the size of the beta. We are popping only the beta element of the stack. Now, for example, initially 0 on this stack and ID is on the top of the ID is the input string. In this case, what you're supposed to do is you need to look into the table of parsing table, that is 0 on ID. That is, you are supposed to look at the action part since it is a terminal symbol. 0 on ID is nothing but S5. So what we do is we'll shift 5 onto the stack. So you can just observe that we have pushed shift 5 onto the stack. Now my top of the stack is 5, and I mean to say that the stack consisting of 0 followed by 5. 5 is on the top of the stack. Star is the input symbol. Then I must look into the action part of the table, that is 5 on star. What is 5 on star? So when you look at 5 on star, it means 5 on star, it is means reduce, that is reduce to 6. Now 6 is the production number, that is F tends to ID. Then what I'm supposed to do is I'm supposed to pop beta element from the stack. So this ID is considered as one element. So I'm supposed to pop ID from the stack. I mean to say that I am supposed to pop one element from the stack. So what we need to do is I'm supposed to pop 5 from the stack. Then after popping 5 from the stack, now my top of the stack is 0. Then what I need to do is on 0, I'm supposed to look at F. What is 0 on F? 0 on F, you are supposed to push 3 onto the stack. So you can just observe that I popped 5 from the stack. After popping 5, I left out with 0. Then I must look at the go-to part of the table, that is 0 on F, which gives you 3. I pushed 3 onto the stack. Now my configuration of the stack is 0 followed by 3. So when I get 3, now my input symbol is star. Once again, I'm supposed to look at what is 3 on star. So 3 on star is reduced to 4. The reduced to 4 is nothing but T tends to F. So when I say T tends to F, so I say that I'm supposed to pop 3 from the stack. Then I'm supposed to look into the go-to part 0 on T. What is 0 on T? 0 on T is nothing but 2. So then I'm supposed to push 2 onto the stack. At the meantime, whenever you reduce, you output the particular production also. Previously, we have reduced F tends to ID. We have put F tends to ID as output. In this case, we have reduced T tends to F. We have output as T tends to F. Now, my top of the stack is 2 and my input symbol is star. So I must look into the parsing table 2 on star. What is 2 on star? My 2 on star is nothing but S7. So I'm supposed to push 7 onto the stack. Now it becomes 0 to 7. So now my next input symbol is ID. Then I must look at the parsing table, that is S on ID. What is S on ID? Yes, 7 on ID. 7 on ID is nothing but S5. I'm supposed to shift 5 onto the stack. So I have shifted 5 onto the stack. So you can just observe that you have written in the action part shift 5. Now my stack becomes 0 2 7 5. Now my top of the stack is 5 and my input symbol is plus. Then I must look at the action part of the table. What is 5 on plus? So what is 5 on plus? 5 on plus is nothing but reduce to 6. So I must reduce F tends to ID. Then I'm supposed to pop one element from the stack. When I pop one element from the stack, so out of this 0 2 7 5, I must pop 5. At the same time, I'm supposed to output as F tends to ID. Now my top of the stack after popping 5, my top of the stack is 7. Then my production on the left hand side is F. Then I must look at what is 7 on F. My 7 on F is nothing but 10. Then I must push 10 onto the stack. So I have pushed 10 onto the stack. Now it becomes 0 2 7 10. Now my top of the stack is 10 and my input symbol is plus. Then I must look at 10 on plus. What is 10 on plus? It is R3. R3 is nothing but T tends to T star F. How many number of elements I'm supposed to pop? I'm supposed to pop 3 elements from the stack because I have T star F. Those are the beta elements. I'm supposed to pop beta element from the stack. When I pop 3 elements, that is I'm supposed to pop 10, I'm supposed to pop 7, I'm supposed to pop 2. After popping these 2, 7, 10, my top of the stack is 0 and my left hand side of the production is T. Then I must look at what is 0 on T. 0 on T is nothing but 2. Then I must push 2 onto the stack. Now my stack becomes what? 0, 2. At the same time, we produce the output as T tends to T star F. Now my top of stack is 2 and my input symbol is plus. Then I must look at the action part of the table, 2 on plus. What is 2 on plus? That is reduced to 2. Reduced to 2 is nothing but what? E tends to T. So I must produce the output as E tends to T. Then I must pop 2 from the stack. Now my top of the stack is 0 and my left hand side of the production is E. Then I must look at what is go to of 0 on E. What is go to of 0 on E is nothing but 1. Then I'm supposed to push 1 onto the stack. Now 1 is the top of the stack, plus is the input symbol. Then I must see what is 1 on plus. 1 on plus is nothing but S6. So I'm supposed to shift 6 onto the stack. So it becomes 0, 1, 6. Now my 6 is the top of the stack. ID is the input symbol. Then I must look at what is 6 on ID, that is S5. Then I'm supposed to shift 5 onto the stack. So we have shifted 5 onto the stack. Now it becomes 0, 1, 6, 5 and my dollar is the input symbol. Now I must look at what is 5 on dollar. So when I say 5 on dollar, it is R6, that is F tends to ID. Then I'm supposed to pop ID from the stack. I mean to say that I'm supposed to pop one element from the stack, that is I'm going to pop 5 from this stack. So at the same time, I should say reduce to F tends to ID. So I must put output as F tends to ID. Now, after popping 5, my top of the stack is 6. 6 on F is nothing but, what is 6 on F? 6 on F is nothing but 3. I'm supposed to push 3 onto the stack. Now, 3 is the top of the stack. Dollar is the input symbol. I must see what is 3 on dollar. Now, my 3 on dollar is nothing but R4. So when I say R4, it is nothing but T tends to F. So I'm supposed to pop one element from the stock. So I'm supposed to pop 3. After popping 3, so I'll have T is the left hand side of the production. Then I should see 6 on T. What is 6 on T? 6 on T is nothing but 6 on T is 9. I'm supposed to push 9 onto the stack. So 0, 1, 6, 9. Now at the same time, I will produce the output as T tends to F. Now my input is dollar and my top of the stack is 9. 9 followed by dollar. What is 9 followed by dollar? 9 followed by my dollar is R1. Then I'm supposed to reduce E tends to E plus T. I'm supposed to pop 3 elements from the stack. That is, I'm supposed to pop 9, 6, 1. So after popping 9, 6, 1, I'm supposed to produce the output as E tends to E plus T. And my top of the stack is 0. And my left hand side of the production is E. Then I'm supposed to see what is 0 on E. That is 1. So then I'm supposed to push 1 onto the stack. Now 1 on dollar. What is 1 on dollar? 1 on dollar is nothing but accept. Now my string has been accepted successfully. Now at the same time, you can just observe that we have produced the output as F tends to ID, T tends to F, F tends to ID, T tends to T star F, E tends to T, F tends to ID, T tends to F, E tends to E plus T. These are nothing but productions are used to construct the parse tree from bottom to top. When you reach this particular level, you have reached the top of the stack, top of the root. That is, you have parsed the string successfully. Thank you.